So I'm impressed. When I was an undergraduate, if it was a 3-day weekend and it was sunny and there was snow in the mountains, on Friday afternoon, no one would be in class. Something's going on. That's because we paid more than they do at the University of Washington. Okay, let's see. We're going to run through this stuff. So, So, a week from next Monday, there's a quiz. Covers chapters 1 through 8, except chapter 3, which we're skipping. 8 you haven't been assigned yet, you can assign the rest of them. You're going to assign 6. Where's 6? So you should read for next week. We're going to take the stuff we've been doing, which is both who the winners and losers are in the marketplace, so looking at consumer surplus and producer surplus, and these pieces on elasticity, and we're going to look at taxes. So taxes are going to be the first actual application of this stuff that you've done in terms of a public policy piece. So we'll be doing that on Wednesday and part of Friday, and depending on how far we get through that, some of that may or may not be on the quiz on Monday. And on Wednesday, I'll give you 20 or 30 questions for you to work off of, and you can ask me questions on Friday. So the quizzes are short answer, similar to the applications in the back of the chapters. Okay. Anybody going to the football game? Somebody is, right? One person. Who's on the football? Anybody else? Anybody know what the ticket price is yet? Price of West Texas Intermediate, however, went up another $3 this morning. So it's up 40 or 50%. Oil, for some reason, is up. And that's more. And you'll be overjoyed to know that you can now buy gasoline, regular gasoline in Madison Park for $3.59 a gallon instead of $3.70. So things are moving. And there's still people buying gas in my shop. Okay. So we're going to do some retreading over this elasticity issue. So the reason we look at this thing called elasticity is because we're trying to see, it gives us the ability to look at how much markets adjust to changes in circumstances. So you want to know that for lots of reasons. You want to know if you're a producer and you have the ability to adjust prices. You want to know if lowering the price or raising your price is going to affect the output very much, or how much it's going to affect your output, so how much it's going to affect your profitability. So if you're a producer, you're looking at that. If you're a policymaker, you want to know, well, I want to tax this stuff. Is this the right thing to tax? How much revenue is it going to generate? Is it going to cause businesses to shut down? Is it going to have a larger impact on one set of people than another set of people? So elasticity, and we're going to look at different kinds of elasticity, is measured because we want to make decisions based on the level of impact either a price change would cause, which is own price elasticity. We're also today going to look at elasticities dealing with income and substitutes and complements as well. We'll start with normal notation for price elasticity. It's the price elasticity of good X is, as we've defined it, the percentage change in quantity over the percentage change in the price of the good itself. So what we're really doing here is somehow we're measuring, look out for a second. When you lower price, when you go from P1 to P2, so you go from here to here, how big a change in the quantity is there? That's what we're trying to measure. And again, we do this in percentage terms because if we measure it just using straight units, so let's say this is milk. If this is quarts of milk, the demand curve may look like that. If it's pints of milk, it may look like that. So you do it in percentage terms so you get rid of the problem of dealing with units. You don't have to go through that way. We're going to say price elasticity, and good, it shows elastic demand. P of X is greater than, greater than 1, and just for kicks. We're just going to invoke right now that we're looking at the absolute value of these things, so we're getting rid of the minus sign. So, and what that means is, when we're saying it's elastic, it means that the quantity response in percentage terms is bigger than the price change in percentage terms. That's all it says. Now, as it turns out, that may mean it's occurring because there are more elastic goods, there are more substitutes related to it. Could be lots of reasons, but we can say something about total revenue associated with elastic demand. Elastic demand means that if you decrease, if you're exhibiting elastic demand and you lower the price, total revenue will increase. If you increase the price, total revenue will decrease. I'll show you why in a second once we go through this. So this is sort of the set of rules associated with elastic demand. Do you have those handouts? And there are two of these. So one's stapled together and one's a single sheet. So just make sure you get two. We also define when elasticity is equal to 1, we define it as unitary elasticity. It seems arbitrary to do that. But as it turns out, there are a lot of goods that exhibit demand right around unitary elasticity for whatever reason. It's also the cutoff point where we start looking at something else, which is inelasticity. In this particular case, when you change price in either direction, total revenue, the change in total revenue is equal to 0. So it doesn't matter which direction you're going, total revenue doesn't change. And what that means is simply that the percentage change in quantity is exactly the same as the percentage change in price. So you may be selling more or less, but you're increasing the price by the exact same amount to compensate that. Again, sort of an arbitrary point, but I'll come back to it in a second. And then we have this thing called inelastic demand. The price elasticity is less than 1, which means that the percentage change in quantity is less than the percentage change in price. And if you decrease the price, total revenue goes down. If you increase the price, total revenue goes up. Back up for a second. These changes in total revenue turn out to be important. They're not important yet, because all we're doing so far is we're looking at what occurs in this particular market. We're not particularly looking at who's selling what or why they're selling it. But what we're going to see, and one of the interesting things about elasticity and total revenue, is we're going to see that firms operate in certain parts of the demand curve, and their decisions are going to be made to some extent. In some cases, they're going to be able to make their own pricing decision and affect how much total revenue they have. In other situations, they won't be, because the market's going to drive them to a particular price. So these will become important at some point. Now, so what I'm about to show you is a characteristic of straight line demand curves. And they'll look a little, you'll say, well, if that's what he's showing me were true, then the world would be a weird place. But it is a weird place, and this makes it very easy to analyze a lot of stuff. For any straight line demand curve, you're going to have different spots on that demand curve that part of it's elastic, part of it's unitary elastic, and part of it's inelastic. And if we draw the marginal revenue curve associated with that demand curve, okay, that's every time you change the price, there's a change in revenue. We'll see that as you lower price over a certain range, as you start lowering price from, say, up here, marginal revenue is positive. What does that mean in terms of total revenue? Total revenue is doing what? If your marginal grade is greater than your total grade, what's happening to your grade point average? We all know this one's going on. Okay, so as long as this is positive, so this is above 0, as long as that's positive, total revenue is going to be going up as you're lowering price. So we can say, that turns out to be the elasticity, the elastic portion of the demand curve. Anybody remember how I drew this? You draw the straight line down to the x-axis and you take the midpoint. You between where it intersects, and that'll give you the point where the marginal revenue curve comes through. As it turns out, so look up for a second. Yeah. So we're lowering price. We start out at this price, total revenue is equal to that. Everybody understand that one? It's just price times quantity 1. Then we lower price, and total revenue gets bigger. We lose this total revenue, right? And we gain that total revenue. Does everybody see that? Y'all got that piece? Yes, sir. Pardon me?
That's price 2.
That's price 2. Here's price 2. And here's Q2. Is that okay? You got that? Okay, what happens next? We go to price 3. What happens then? Well, now we lose all this. Right? Everybody see that? And we gain this, which is larger. Everybody okay so far? So that rectangle there, which represents total revenue, keeps getting larger as we lower price until we get to this point, which is the reason for red markers. P4 and Q4. We reach a point where that's the maximum total revenue that you can get under this demand curve. And another way to look at it, in a simpler, if you're a visual person, this is the largest rectangle that fits underneath that straight line. That's why it's maximum total revenue. And it happens to be at the point where marginal revenue is equal to 0. So keep in mind, I'm not asking you to apply this at this point. I'm asking you to understand the mechanics. So underneath any straight line demand curve, you're going to have a maximum size rectangle that's going to represent the largest total revenue possible under that demand. That, by chance, this particular point is unitary elasticity. Now what happens if I lower price beyond that, beyond P4? You start losing stuff, and you can see it. Now we lower price to P5. Okay, we lose this, and we gain this, which if I had drawn it accurately would in fact be smaller than the And as we go on, you can see it even more and more exaggerated. We go to P6, we gain this, and we lose all this. So this is the inelastic portion of the demand curve, where if you lower the price, you're losing total revenue. Likewise, if you're in the inelastic portion of the demand curve and you start raising price, that total revenue starts getting larger. For now, you should just understand the simple mechanics of this. There's a point where you have the largest possible rectangle. That represents the quantity and the price at which there's unitary elasticity. At a higher price is the elastic portion of the demand curve. At a lower price is the inelastic portion of the demand curve. It's a set of mechanics having to do with straight line demand curves. The fact of the matter is, generally speaking, when we're talking about markets, we're not talking about demand curves that go from $132 to $2. So we're not normally working over that expanse of prices in a marketplace. We're normally looking at, here's the price of milk, and it's between $1.90 and $2.40. And we're trying to measure elasticity. So we might only be looking in this range. So we're not normally looking over this big, huge range in the on the demand curve. So that's the first thing to note. We're doing a lot of this analysis with a model that has different elasticities along the demand curve we're using. And it doesn't matter if it's shaped like that, or it's a lot flatter, or it's a lot steeper, it still has these same qualities. You have an inelastic portion, and you have an elastic portion, and you have a unitary portion. And those total revenue relationships are going to always exist. Now, having said that, I'll show you a couple of other things that we'll have to get used to. There's quantity per unit of time in dollars. There are two demand curves. One is steeper than the other one. If the one demand curve is steeper than the other one, we say it's more elastic. And what we mean by that is that the response in quantity terms, percentage terms, is greater. Likewise, steep one's inelastic, the flat one is elastic. And it's conceivable, although I don't think you really see these, it is conceivable, you would have that would be a perfectly inelastic demand curve. In other words, the quantity doesn't change regardless of what happens to the price. So you're on your deathbed and there are drugs out there, you don't care what the price of that drug that will cure you is, you're still going to demand the same amount. So there's some goods that there are just no substitutes for. There's an immediacy to it. The only thing I can think of is sort of life-saving events. But it is plausible you could have very inelastic demand. And in general, you might have very inelastic demand for certain goods in the short run, so food or water or things like that, where the price effects affect the quantity that people need or want very little. So this would be considered perfectly inelastic. And perfectly horizontal curve would be considered perfectly elastic. And what that means is, if you change the price just a little, people won't demand it. It's price becomes the constant in this one. Now, if you look at the papers that I passed out, look at the one that's stapled together first. You can see when they actually estimate demand, the first one on there, of course, is salt. Did you guys get those yet? No, there should be enough. Where did they stop? There. Did you think they were going to magically move? Pretty good. You guys got it? Salt. So if you look at these elasticities, you'll see the first category is inelastic goods, and they range from the ones they're showing, gasoline in the long run to salt and matches and toothpicks. So salt and matches and toothpicks have very tiny elasticity measures, 0.1. And the reason for that is they're a very small part of your budget. You just don't really care. And you go, again, if I asked you the other day what the price of toothpicks was, you wouldn't know that anymore than you knew the price of salt. So that's why that is. It turns out that airline travel in the short run is very inelastic, as is gasoline. But look what happens to gasoline in the long run. It goes from very inelastic, 0.2 to 0.7. That's because you start using public transportation, you get better cars, you start riding a bicycle, you walk more, whatever the case may be. All those things are substitutes. You're getting more substitutes over time. Is there anything else interesting? Tobacco products in the short run, physician services, all inelastic. And then if you look at unitary elasticity, these are just by chance. Moving, housing, shellfish, they're all about 1. And then if you look at goods that are elastic, you'll start to see restaurant meals are 2.3, foreign travel in the long run, airline travel in the long run. So what do people start doing? Well, in the short run, you may have to make that trip. In the long run, you just go to a meeting, or you don't make that trip, or you change your vacation from going to Europe to going to California, depending on what the price is. And then you'll see things like fresh green beans and fresh tomatoes have really high elasticities because there are lots of substitutes. And then you see Chevy automobiles, which are really high. And as we'll see in a few minutes, that the income elasticities for those are also relatively high. So we have these goods. They have various sorts of elasticity measures. Most of the reason for the elasticity measures is the number of substitutes that exist. And we're basically measuring something about the slope of this thing. We're saying, if we say that the demand curve is steep, we mean it's relatively inelastic. If the demand curve is flat, we mean it's relatively elastic. All we're looking at is the relative difference between the percentage change in price and the percentage change in quantity. As it turns out, what you'll see next week, is if you're going to start taxing these things, you want to target certain things for particular reasons, largely to do with elasticity. We also have another set of elasticity measures. The first one being cross price elasticity. Cross price elasticity is equal to the percentage change in the quantity of good X caused by the percentage change in the price of good Y. And look up for a second. There's a market for something. Margarine and butter turns out to be a good one to look at. Everybody look it up? Good. Okay. When we're measuring price elasticity, we'll say this is butter. The market for butter, we're looking at the effect of a change in price along that demand curve. So that's movement along that curve. When we're looking at cross-price elasticities, we're looking at how big a change occurs when you change the price of margarine. So it's either a price of a substitute or the price of a complement. How big is that shift so that this quantity changes? We're looking at a new equilibrium position. So cross-price elasticities are measuring a somewhat different thing. And if the percentage change in quantity of X over the percentage change in the price of Y is greater than 0, we say the goods are substitutes. In other words, the price of one thing goes up and you demand more of the other thing, you're substituting away from the relatively more expensive one towards the one that's relatively cheaper. So, and we'll take this a step further. Well, we'll leave for a second. Likewise, if the percentage change in quantity or the percentage change in price is less than 0, these things are complements. In other words, if you start demanding less of one good because the price of another good went up, those goods are considered complements. Again, all we're measuring here are how big are these shifts and what the direction of the shift is given the characteristic of the good. Now, as it turns out, we can also start looking at how strong complement things are. So if cross-price elasticity is very high and very positive, we'll say these things are really good substitutes for each other. And likewise, if you have a very large negative number, we'll say they're very complementary and move together very closely. Now, we use these in taxation and we use them in policy work, but most of what goes on in marketing these days. So if you go into a Nordstrom store and you look at how it's laid out, even the way the escalators are laid out. It used to be 30 years ago, 20 years ago in Nordstrom's, the escalators all went up. You got off one escalator, you took a step, and you went up another escalator. Well, they now make it so you have to walk around and they force you to look at other stuff. And they put things together. They put things that they think are complements together. So if they think you'll buy this thing with this thing, they'll put them together. They do it by age. Certain characteristics of certain clothing for certain age groups will all be put together. They're looking at complements. They do the same thing with substitution. Marketers do very sophisticated econometric studies, basically looking at substitution effects and the degree of substitution effects and how much pricing analysis they can do with them. If you look at the second page that I handed out, if you look at the bottom of that, you see butter and margarine are relatively strong substitutes. The cross-price elasticity is 0.81. Beef and pork are substitutes, but they're not as close as butter and margarine. And the entertainment in the food one is entertainment and restaurant food. I should have specified that clearly in the table. What happens is if they go up, what you're doing is going out you're demanding leisure or time out for an evening. If one of them goes up, both of them suffer in terms of how much gets consumed. But they're actually complements. You've seen chicken fillet commercial with the cows. There are a whole bunch of them out there. That's looking at chicken and beef as substitutes for each other. And the cows, of course, have figured that out. So the whole commercial is based on cows knowing about cross substitution and elasticities. Okay, last one. Any questions on this one? Percentage change in the quantity that someone buys of a good when you change income. So, if this is greater than 0, we call it a normal good. Some people classify goods into normal goods and luxury goods and say if the income elasticity is greater than 1, then it's a luxury good. Turns out that the luxury classification has some relevance, which we'll get to. And if income elasticity is less than 0, we say it's an inferior good. Again, these elasticities have policy implications. So if you look at that, the top of page 2 of the second sheet that I handed out, you see automobiles have these are new automobiles, have relatively high income elasticities. Books are relatively high. Person's own life, which is a measure of insurance that they make, has low income elasticity. Restaurant meals are high. Tobacco is low. Again, tobacco is one of those things where there's a syntax associated with it. Income doesn't seem to have an impact. Then if you look at margarine, you see that it's negative 0.20. In other words, when people start making more money, they start buying butter instead of margarine. That's all we're measuring there. In public transportation, as people get more money and they can afford to park at downtown parking prices, they substitute away from the buses and away from the trams towards driving themselves, which is why it looks like an inferior good there. Those become important and are used in lots of policy decisions because we tax things differently. So for instance, what we're going to see is that things that have very low income elasticities, we try to avoid putting sales tax on. So if you look at food is exempt, certain sorts of medicine is exempt, diapers I think are still exempt. Because we're trying not to tax low-income people. At the same time, since 1990 or so, we have in the United States something called a luxury tax. So automobiles and boats and lots of things, jewelry that's over a certain price has an extra federal tax attached to it because it's considered it's a luxury and we're just taxing the rich. People don't even realize it's out there. It's another one of these taxes that just sort of got put in place and we never saw it again. The income elasticities do drive a lot of taxation decision-making issues. And we'll see that next week when we talk about sales taxes and the impact of sales taxes in the marketplace. Okay, and again, with the income elasticity, we are simply looking at a demand curve and a supply curve and how that demand curve shifts when we look at, here's income level 1, here's demand and income level 2, and income level 2 is greater than income level 1. And it's just looking at the size of that shift. Anybody have any questions on this? No? Okay, we're done for the day. I was going to do taxation today, and then someone reminded me you got to read it first, so you're getting out a little early. So Wednesday and Friday we're doing taxation. Read the taxation piece. Now say
Did you see it? What, the first I wrote?